Designing linear structures like roads, railways, or waterways can be accomplished with complementary tools within AEC Collection. Those tools are mainly InfraWorks and Civil 3D. Let's have a close look to capabilities of both products. InfraWorks is a dedicated tool for preliminary design stage, enabling to create large-scale existing context in few clicks. The first choice might be Model Builder, built-in functionality creating context from publicly available data. The second option is to aggregate data from different sources like GIS data, 3D models, photos, point clouds, and so forth. InfraWorks has rich and easy-to-use capabilities to create preliminary infrastructure design, including bridges, tunnels, and other civil structures. Design can be then analyzed to make sure that fulfills required capacity or design standards. Important part is possibility to quickly and interactively visualize the design within real-world context for different audiences. Civil 3D contains not only functionality of Civil 3D, but also full AutoCAD. Full AutoCAD we call AutoCAD 1. As it contains more AutoCAD flavors, where some of them are really infrastructure related, like Map3D and raster design, and I will cover in the next slides. There are also some which might not be directly connected with infrastructure, but some of them might be helpful for infrastructure, like for example, Plan 3D functionality. Autodesk started to develop Map3D to enable CAD users to utilize GIS data within AutoCAD, and also being able to edit GIS data and bring it back to GIS repository. In fact, it was before Civil 3D started. The point is that Map3D is using technology called FDO providers, feature data objects. It's open source technology supported by OESGeo, Open Source Geospatial Foundation. Developers make the providers they develop available for free. They can be integrated into AutoCAD Map3D toolset and then used to access additional data formats not included in the box. Civil 3D is based on dynamic model, which means you can do some changes in one place and it is automatically propagated on all derived, or we can say dependent objects. For example, changing profile will trigger corridor rebuild, and cross sections will be updated automatically, including volumetry calculation. Civil 3D toolset enabling you to work with all necessary components on linear structures, from marine surveying through design and volumetry calculation, up to drawing deliverables creation, volumetry calculation, and set out data generation. It addresses also different flavors of infrastructure design, like road and rail, or road rehabilitation, or landscaping. I'm used to say that Civil 3D can be used anywhere where you are modeling or changing existing ground. Civil 3D also enables to work with other different Autodesk products. Example can be bidirectional connection to InfraWorks or possibility to share data with Revit, but obviously many more, enabling you to deliver projects with desired outcomes. Civil 3D has a number of additional modules which can help you with your processes within infrastructure design. Country kits are important for countryfication of Civil 3D to local standards. It brings to you project local standards, libraries, and drawing styles to fulfill country-specific requirements for deliverables. Grading optimization enables you to perform grading design based on specific project constraints, explore alternatives to achieve an optimal grading. You can define design goals and at the beginning, for example, slopes, cut fill balance, elevation at specific points like drainage, inlets, and so on. And module will automatically offer you the best solution based on given constraints. Geotechnical model streamlines geotechnical layers modeling, and it automates processes from important borehole information, surface layer modeling, and stylizing output in plan and profile. Then, building information modeling is not only about 3D model creation. Very important is I in the acronym, which stands for information. Standardized data tool helps you to manage the data easily. There are three components. Standardization helps you to ensure that your data in your models meet required standards. After adding data, you can validate model information, basically to check models to ensure compliance and performance takeoff. The last one is to deliver. You can report compliance and extract data to a single spreadsheet. Vehicle tracking is analyzing tool which enables you to check if your design can be utilized by specific vehicles. For example, if specific truck can be driven through your junction. You can use a built-in library of vehicles or create your own one. Talking about library, I would like to stress Autodesk is providing users with country-specific design vehicles within country keys mentioned earlier. You can report and animate the results to have indication that your design satisfies the required criteria. You can also, for example, check how many parking lots can be hosted by parking lot within your design. The last but definitely not least, I would like to mention Dynamo for Civil 3D. It is a visual programming tool which can help you to reduce time on repetitive tasks. How boring can be to insert point objects to your design like sleepers or traffic signs. Sleepers on rail or crash barrier along the road are positioned regularly with the reference to some line, for example alignment or road edge. Why not to leave on Dynamo to position those objects automatically? And if design is changed, to rebuild them with the reference to the new position of line. Dynamo for Civil 3D is not rocket science. It is used by engineers to streamline the processes. You do not need to be a programmer to use it. In fact, it democratizes scripting to engineering community. Dynamo can become your Swiss Army knife for your design.